In the previous lesson, we learned about data frames. Specifically, we learned about the fact that data frames have columns, and each column represents a variable, and a data frame has rows, and each row represents a specimen. And then we learned that the values in columns are called variables because across the rows, values in the same column may take on different values, right? They can vary. That's why each column represents what is called as a variable. So for example, if you have a column called age, there may be different age values in the same column. So age is called as a variable. Okay, and the data frame that we saw in our example last time was it had 5 variables. And the rows represent specimens, and each row in our earlier data frame represented a student. And the other important thing that we learned about was the fact that in order for a table to qualify as a proper data frame, really each value in a column must be of the same type. Okay, so for example, if you have a column called age, every row in that particular column has a value which is the age of one of the specimens. And similarly, every row of a data frame must represent the same kind of real world object. In our earlier data frame, every row represented a student. You could have another data frame in which every row represents a country, or every row represents a book, or every row represents an instructor or a course, anything. But every row has to be of the same type. And then we learned another idea, which is the notion of sample versus a census. Okay, sample is just not the entire collection of possible specimens, and most of the time in statistics we are working with samples. Okay, in fact the whole idea in statistics is, well, given that I have information in a sample, how can I try to make conclusions about the entire census? Okay, so that's really one of the goals of statistics. How can I make reliable conclusions about the entire census of the entire population based on just a subset of it, namely the sample that we are working with? But we'll work towards all of that gradually. So the next thing we're going to do is to learn how to use data frames in the R statistical language. Okay, so in this course we are going to be using a statistical package called R, and this is an industry standard package. Lots of data analysts, data scientists, etc. use R. It's an extremely powerful software package in which you can do all sorts of data related things, and we are going to be using R in this course. Okay, now unfortunately the aim of the course is not to teach you the complete language of R, but just to teach you enough about R so that you can do things that we teach in this course. Okay, so in fact, if you're more interested in learning the entire language R, then there would be other courses that you can take later and learn the actual language itself. For now, we are going to just learn enough R to do things that we need to do in this course. Okay, so in fact, what you'll see is if you go and look at the book, in the the book that I had referred to, Lessons in Statistical Thinking by Daniel Kaplan. So within the book, directly inside the book, you'll be able to use the R package. But what I've organized is that each of you will get your own access to the R package. Now that'll happen after the add drop portion of registration finishes. After that, the moment you log into PirateNet, you will see your R package available, and I'll show you how to use it and all that. Okay, for now I'm just going to show you some R commands, and hopefully in class I'll be able to actually show you how to use all of these things directly. Okay, now the R environment that you're going to be using, it has a data frame called births 2022. Okay, that is about information about the children born in the year 2022. Okay, so that's the data frame. So here births 2022 is a data frame. Okay, now what we are doing is we are using this symbol, which is a vertical bar, which is on the right hand side of your key. You'll see there is the right above the enter key, there's the backslash and a shift with backslash that produces the vertical bar. And then this is the greater than sign. Okay, so vertical bar greater than together they make up the symbol in R. It's called as a pipe. It's an operator. Now don't worry too much about it. I'll be explaining it shortly. Okay, so what we are now saying is take the births 2022 data frame and execute the function whose name is head, okay, and give me the result. This is what we are saying. Okay, so when you do this is our code, and you will be typing this kind of code in the course to get your job done. It's very straightforward, and basically I'll be showing you different templates and you can just use those templates. You don't really have to learn too much of R. Okay, so just focus on the template. So here the structure is data frame, pipe, function. Okay, that is what applies the function on the data frame. Okay, now what does the head function do? Okay, so this is the result of typing in this particular command. Okay, and I'll show you exactly where you'll type in the command, etc., etc. All that we'll see when we actually use R in class. Okay, so births 2022, and then you pipe it into the function head, and this is what the result is. Okay, so the function head, essentially what it shows you is some of the rows in the particular data frame. Okay, now a data frame may have 20,000, 30,000 rows, it can have lots of data. Of course, you don't want to look at all the data. Here, what we are doing is we are saying, just give me a sample of what it looks like so that I get an idea of what this contains. Okay, so what this is telling you is that there are several variables in this data frame, as we would expect. The variables are named month, DOW, which is day of the week, place, where the child was born, paternity, MEDUC, which is mother's education, father's education, whether the people were married, father's age, mother's age, and how many kids totally the parents have, and uh, you know what is the interval uh, of this child, what is the prenatal start, etc., etc., etc. Okay, and then it says in addition to all of these variables, there are 26 more variables in this data frame, and here are the names of the 26 additional variables. Okay, so this is a really large data frame. It is a real live data frame, but again we don't have to worry about the details. What I'm showing you is, given any data frame, you can get a glimpse of the initial rows in the data frame by typing in the command data frame pipe head. Okay, so if instead of births 2022, if you put a different data frame, then you will get a glimpse of the initial rows in that data frame. Okay, so head is the function that is used to see the initial 5 rows. By default it shows 5 rows. Okay, so what is a function? We know from high school you have all studied about functions. Well, function is basically uh, it's a box. In this case it's like a black box. You don't really need to know the details of how it works. You just need to know what it does. So in this case I take the number 81 and I pass it to the function square root, and of course I get back the result 9. Okay, so a function is is a computing object of some kind. Okay, it does some computational, well understood computational operation, and you provide it an input, it will perform the operation and give you the output. Okay, that's really all we need to know about a function. Of course you have all used Excel and you know what many of the Excel functions are, like max and min and square root, and there are so many functions that you have in Excel. So this is the same idea. It's a mathematical thing, right? So in R, this is the input. It's also called the argument, and 9 is the output. In our terminology, it's also called as the returned value, right? That is, you give the function an argument, and in return, it gives you the result. Okay, so the general pattern, this is a specific example of a function. The function I'm calling it a square root. Okay, That's not what it's called in R, but this is just a mathematical explanation. Okay, that's a specific example. The general notion of a function is you have function and you supply it in some input arguments. It doesn't have to be only one argument, as in this example, this had only one argument, but a function could have many arguments and it produces some output, which is the return value. Okay. Now what the function does will be determined by its name. Or in other words, people who write functions will give it appropriate names so that just by reading the function name, we'll get an idea of what it does. So square root is an appropriate name because this function is computing square roots. Okay. For example, another function name could be, square, or it could be a function name could be mean, which computes the average, and so on. Okay. So here's an example of a function with two arguments. Okay. Suppose I have a function whose name is difference and I pass it two arguments a and b. Okay. So I push the value 100 to a, I push the value 10 to b. Okay. Now obviously you can figure out what the result of this is going to be because the name of the function is difference. So likely it's going to tell us the difference between a and b. In other words, it's going to give back to us a minus b. So we expect that this function will return to us 90. That's what the function does. Okay. We are seeing trivial functions at this point, but of course the reason we are using functions is we will be doing many complicated things in R. Okay. And we don't want to get into the details of how those complicated things are done. Okay. We'll just say, hey, compute this function for me. Okay. It's more like less like going to a new town and you get into a cab and then you tell the cab driver, I want to go to place X. Okay. And they'll take you to place X. You don't need to know about the details of how to get to place X. They'll take you there. Okay. That's what a function is. You don't have to know the details of the computation, but all you need to know is, well, if I give it these values, then it's going to give back the computed result of whatever the computation is. Okay. So in this case, we are giving it two inputs, or technically called two arguments, and function gives back one result. Now all functions give back only one result. Only a single object will be returned from a function. Okay. Of course, it may look like it's very restrictive. Oh, only one object. Wow, that looks like very restrictive thing. That's really not the case, because that single object that the function returns can even be a data frame. Okay, which contains lots of rows and columns, and it could have hundreds of thousands of rows. Okay, so it's one single well-defined R object. Now that object doesn't have to be a single number. It can be a collection of things. Okay, so here if we say births 2022 and you use the pipe operator and give it to head, what you're really saying is, hey, head function, take births 2022 as an argument and give me back the result. So the object is births 2022. This is the pipe, and through the pipe we are giving it to the function called head, and the function called head gives back the results. Okay, so it's something like this. Okay, so you have births 2022, and through the pipe, through the arrow, you can think of this arrow as really the pipe. Through the pipe we are pushing it into as an argument to the function head, and it gives back the result. Okay, so you can think of that arrow as a pipe. Okay, so in order to supply an argument to a function, we are using the pipe operator, right? We are using the pipe as a mechanism to feed a value into a function instead of directly saying head and within parentheses births 2022. Okay, there's a good reason we're doing it this way, and we'll see that soon. Okay, so what is a pipe? Why do you call it a pipe? Well, think of it literally as a pipe. Okay, just we are using births 2022. There's a pipe, we are throwing it into the pipe, and then when it comes out of the other end of the pipe, it's being fed as the argument to the function head. Okay, and of course we've already seen what the output of the head function is. It shows us the initial few values in the data frame. How many rows is that? 1, 2, 3, 4, 5 rows. And for every row, it's giving us as many columns as will fit on your screen, and the columns which won't fit, the variables which won't fit, it simply lists those variables here. And for every variable, it is telling us what type of variable it is. Okay, so you're seeing here variables like double, CHR, character, ORD, etc. Of course, in this course, we are only interested in numerical and categorical. Okay, so anything that is numerical, for example, it says int is integer, well, that's numerical. DBL is double, well, that's also numerical. Everything else just treat it as categorical. Okay, anything which is not numerical, just treat it as categorical. Okay, so what do you think the function tail will do? Just based on what you saw head doing. Well, head gave us the initial few rows. Tail is going to give us the last few rows of a data frame. That's all. Okay, just by the name you know what it does. You don't have to know much more than that. Okay, births 2022, if you pipe it into the function n row, what do you think it does? Well, n row tells us the number of rows in births 2022. Okay, so it'll come back and tell us how many rows are there in the function, in the data frame births 2022. Well, how about births 2022 and you pipe it to the function names? Okay, that is going to tell us the names of all the columns or the names of all the variables in that particular data frame. Okay, now these are functions that you will be using very, very often. Tail you may not use that much. Head, yeah, you'll use that quite a bit. N row and names are functions you'll be using all the time. Okay, so it's a good idea for you to simply memorize some of these simple function names. I mean, you won't have to memorize more than about 10 function names in this entire course. Of course, you don't technically have to memorize it. You can write it down and you can refer to it whenever you want. In fact, even in the exam, you don't have to remember function names. Okay. Similarly, ncol tells us how many columns there are in the births 2022 data frame. Okay, so let's take some example. Okay, so there is a column called MEDUC in this births 2022 data frame. It tells us what is the mother's education level, right? So remember, the births 2022 data frame contains data about all the births that occurred in the year 2022. And for every birth, it has information about the child that was born, like weight, height, etc. And also information about the parents of the child that was born. So here, this column or variable meduc tells us what is the mother's education level. Okay, now suppose we want to find out, okay, let's say there were, I'm just saying, giving a number, let's say there were 2000 rows in this data frame births 2022. Okay, out of these 2000, what were the different education levels and how many people were there of every education level? Okay, now remember, education level is a categorical variable. So I just want to find out, okay, let's say the education levels, I don't recall what it is in the data frame, might be like, high school, undergraduate, postgraduate, etc. Okay, how many people were high school? How many people were graduate, etc. Okay, that's what this is. And the result comes out like this. Okay, so uh, the less than 8 tells us how many people had an education level less than 8th grade. So in our data frame, that was 640 people. Well, this data frame has far more than 2000 people. Okay, so less than 8th grade was 640. Between 8th and 12th grade was 1455. Okay, and people who are between 8th and 11th grades, I should say, less than 12. Okay, and the number of people who only completed high school is 53, 52, etc., etc., etc. Okay, so the single function called meduc does all this work for us. Okay, it goes through, let's assume the data frame had 10,000 rows. It went through all of those 10,000 rows. It looked into this column and it counted how many values were there for every level of MADUC, and then it gave us the total. Well, it did a lot of work for us, and all we had to do was just say, hey, count. That's the power of using a function. You know what the function does. In this particular case, if you were asked to do it manually, you could do it, but it's just that it's going to take you a hell of a lot of time. This will probably take you several days if you were to do it manually, but the computer can just crunch it and give you back the result in a fraction of a second. Okay, so that's an example of a function, and this is what we are going to be doing in this course. We are going to be using various functions like this to do lots of uh, complicated sometimes tasks or simple tasks but voluminous amount of work. Okay, so we already saw what the count function did. Okay, so you can use the same functions on any other object. If I missed the word use here. Okay, so for example, there is another data frame in our data set. It's called rail trail. Okay, so instead of births 2022, if I say rail trail tail, it's going to give us the last few rows in that data frame. If you did n row in the data frame called 10-mile race, that's another data frame which is available to you. We'll be using some of these data frames in the course. Okay, and if you do n row, it's going to tell you how many rows are there in the 10-mile race data frame. Or if you take the Saratoga Homes data frame and give it to the function names, it's going to tell you what are the variable names in that particular data frame. And finally, there's another data frame called SnowGR, and if you pass it to the function ncall, it's going to give us how many columns there are in that, how many columns there are. Remember, names tells you the column names, ncall tells you the number of columns. Okay, so you can understand the general pattern here, right? You give a data frame name, put the pipe, and then put whatever function you want following the pipe. You will get the result of applying that function on that data frame. Okay, now given any data frame, you want to know what is in that data frame. Okay, meaning, okay, you're saying MADUC, and that's the mother's education. Well, how am I supposed to know that? If I just get the data frame and it says MADUC, how do I know that MADUC stands for mother's education? FADUC stands for father's education. You know, the column names are cryptic. I don't know what they contain. And also there might be a column called height. Well, we know that it's going to give us the height, but what is it giving us the height in centimeters, inches, meters? What is that, right? So we've got a lot of information that we may still need. Just the data frame alone won't do. We get that additional information in this thing called the code book. Okay, code book basically describes the data frame to us in plain language. Okay, now in R, if you want to find the code book for any object, you can just type the question mark in the command. Question mark, if you do this, if you type this command, question mark births 2022, it'll give you textual description of what is in that data frame. Okay, so it says month is 1 to 12. Okay, so we know that month is not January, February, March. It is the numbers 1 to 12. TOW, it says, is date of the week, and it's like that, Sunday, Monday, Tuesday. Place tells us where was the child born, hospital, home, clinic, etc., etc. Right? So it's here you get the information about what is in every column, and also if required, in this particular case, what we are seeing here doesn't require, it will give you more information. For example, if it's height, it will tell you that this is the height of XYZ measured in inches or measured in centimeters or measured in meters or whatever. Okay, that's what is called as the code book. Okay, now suppose you want only some columns from a data frame, right? As you already saw, our data frame had a huge number of columns. We saw that your data frame could have many columns, and often we are only interested in a small number of columns that we'll work with. Okay, so in order to make life easy for ourselves, we can just pick out the columns that we are interested in for analysis. And we can do that by using the function called select. Okay, so in this case, I'm saying from the births 2022 data frame, which had a huge number of columns, probably 40 odd columns, give me only these particular columns that I have named. Okay, give me the columns M age, M educ, duration, weight, and anesthesia. Okay, so it's going to come back and give us just those particular columns that we want. Okay, so we use the select function and we just name the columns that we want, and here's the result that you get back. Okay, notice that the result contains only the columns that we asked for, whereas earlier when we said births 2022 head, we got a huge number of columns. Okay, in fact here it tells us how many more rows there are. So it gave us 10 rows, I think, and then it says there are 19,990 more rows. So okay, so this data set has 20,000 rows. Okay, so we are using pipes to ease the workflow in when we work with data. Okay, that's where the real benefit comes. So what we can do is we can say births 2022, and then we send it through a pipe into the select function. Okay, now the select function is going to return a data frame containing only these columns that we had asked for. Okay, so the output of the select function, once again we are sending it through a pipe into this function called head. Okay, and out is going to come the result. So it looks like this. It says birth 2022. We pipe it into the select function. Okay, so and then the select function finishes its work and pipes the result into head, and you get now the first few rows in this data frame that came with only these columns. You don't get all the columns.